Now that you've watched the lesson on all the different properties of equality or properties of congruence, and we've taken a look at writing our first proofs, now we're going to get into actually writing some proofs, and we're going to look at two-column proofs to start. But before we actually do this, I want you to go through and solve this equation. When you get it done, or push pause, solve the equation, then when you get it done, push play again, and I will be on the next screen. So here we go. Now this is the same thing. Again, notice we have that same equation that you've already solved. So you should have got to the point where you figured out that x equals 2. And I have all my work already done. Now the actual proof part of it, there's two sides. There's the statement side over here. Oops, didn't want that. So that's the statement side. And then on the right side, we're always going to have the reasons. And every statement that you make has to have a reason for what you said. So my first one, I come in here and, well, I wrote down the exact same thing that was given. So my reason for that is nothing more than given. That's the given information. The problem stated it, so we can just say that it was given. That's how we know that it must be true. Now we go on here to step 2. What did I do to get to step 2? Well, what I did, and you may not have done it this way because there's multiple ways to solve an equation, but I distributed this 3 into everything that's in the parentheses. So I used the distributive property. So my reason, distributive, and I'm going to abbreviate the word property, just like that. And what I want to see you do is I want to see you give reference numbers. Now a reference number is stating which statement did you use to come up with the one that you just had. Well, in order for me to say what I have here in line 2, I needed to have line 1 first. I couldn't have done it without line 1. Therefore, my reference number is number 1. Move my way down. The next step in my solving my equation, notice, I added 5 to both sides of my equation. Left side, right side. So if you remember back to those properties we had, this would be referred to as the addition property. And I'm actually going to abbreviate this as well. I'm going to use, the plus sign. And that won't go away because it's invisible ink. But there it's gone. So I'm going to use the addition property. And I've stated it. Now, my reference number, well, I needed to have number 2, statement 2, to be able to do number 3. Now, technically, I needed 1 also, but we're only going to write down the statements that we directly needed. Go on here to step 4. Now, in step 4, if you notice, I used the division right here. Used my little division signs, or bars, and I divided by, oh, look at that. Oh, no, I'm sorry. I didn't use the division. That's my equal sign. Little mistake there. So what I've done here is I'm going to use step 2 and step 3. I'm going to put my reference numbers down first. So you're looking at both of those pieces. And in to go from step 2 to step 3, notice I added 5 to both sides, which was my reason for 3. And now what I'm doing is I call it simplifying. So I have that 3x minus 5 from line 2, the plus 5 from line 3. Put it all together, I get 3x. Well, that's referred to as substitution because I'm replacing the 3x minus 5 plus 5 with just 3x because it's equal to that. Substitution. See if I can spell. So that's our substitution property. And then if you look at the right side of the equation, in line 2 I have the 1, and on line 3 I have the 5. So I take 1 plus 5, add it together, I get 6. I've replaced 1 plus 5 with 6 because 1 plus 5 is equal to 6. Now when I get to line 5, I was a step ahead of myself. This is where I'm doing my division. Those are the division signs right there. So I've divided by 3 on both sides of the equation. Therefore, I use the division property. And I just use the sign for division to do that. And then in order for me to actually be able to write statement 5, I needed to have statement 4 as my reference. And then when I get down here to line 6, well, now I'm using line 4 along with everything that's here in line 5 to come up with this last equation. So what I'm doing is I'm taking 3x, dividing it by 3, and I just get x. So I've replaced 3x divided by 3 with x. If I replace something with what it's equal to, I am using substitution. So there's my substitution property again. and I needed, notice how I talked about line 4 and line 5. It's kind of your dead giveaway as to what are your reference numbers. And here's a 2-column proof. Solve an equation on the left side. You've already done that. It's the right side that's new. Just giving a reason for every one of those lines in your proof. Here's another example, very similar. Start off with the given information. It's kind of a handy place to start a lot of proofs. You don't always have to start with the given information, but a lot of times it's kind of an easy start. And being it is the given information, that is my reason. Now I'm going to take a little different approach to solving this. Many of you would probably go on to step 2 and you'd use the distributive property. I'm going to take a different approach, and I'm going to divide both sides by 7 just to show you another way to solve this equation. So step 2 is my division property, and then I needed line 1 to be able to do that. Now when I go on here to line 3, I'm going to do this simplifying. Well, my 7s are going to divide out, and then all I'm left with is 2x plus 1 on the left side equal to 9 on the right side. Well, what I did is I replaced all of this stuff right here. Let me get this. Right here, I replaced all this. Okay, it's going to highlight it there with the 2x plus 1. So when I replace something with what it's equal to, that's referred to as substitution again. And I did the same thing on the other side. Replaced this with what it's equal to. So substitution property, and then, oh great, it all went away because I used the magic pen. Let me rewrite this again. And I use line 1 and line 2 to do that. Continue on in my proof. Now I want to get rid of that 1. So in my line 4 of my proof, I'm going to subtract 1 from both sides of the equation, which would be referred to as the subtraction property. And if you just want to use the minus sign, subtraction property. And I needed line 3 to be able to do that. I move on to line 5. And now I need to simplify all my stuff. So I'm going to take all of this and replace it with what it's equal to. And all of that is equal to 2x. And then I'll do the same thing on the other side of the equation, replace the 9 minus 1 with 8. Well, I use the substitution property. And that is not how you spell it. Substitution. There we go. And I needed line 3 and line 4 to be able to say that. Moving on, in line 6, I'm going to divide both sides by 2 to get rid of the 2 in front of the x. That will give me the division property. And I needed line 5 to be able to do this. And then last but not least, I'm going to do my simplifying or substituting. So 2x divided by 2 is x, 8 divided by 2 is 4, and my line 7 is going to be the substitution property again. And I needed line 5 and line 6 to be able to say that. Now some of you are going to ask, when do I finish a proof? Well, you are done with the proof when you get to what you're actually trying to prove. So when you notice here, we were trying to prove that x is equal to 4. Well, the very last line in my proof says x equals 4, so I know I'm done. Don't go any farther. You've completed it. One more example here. Now this one kind of puts a little bit of the equation solving together with what we were doing with the geometry. And now in this one, it gives us this if-then statement. So I want us to think back to the 5 steps of writing a good proof. Step 1 was to write the conjecture or theorem that you're trying to prove. Well, I'm not going to rewrite it again because it's right here. here's step one, writing that if-then statement down. Now, step two was to state the given. And remember, if you have your if-then statement, the given information is going to be found in the hypothesis of the statement. So that's all of this stuff right after if, all the way to right before then. There's your given information. So what I'm going to do is I'm going to write that like this, given. So my first given piece of information is the measure of angle ABC plus the measure of angle CBD equals 90 degrees. There's one. I have another piece of given information. It tells us that the measure of angle ABC equals 3x minus 5. It also tells us the measure of angle DBC equals x plus 1 over 2. So I've done step one, and then this is technically step two of writing a good proof. Step three was to draw a picture and mark it up. Well, the picture's already here, but now this is the part where I want to mark it up. And when I say mark it up, I'm just going to take all this given information, I'm going to put it in there. So the first one tells us that the measure of angle ABC plus the measure of angle CBD, well, that looks like the two little angles in this whole big one is 90 degrees. So the way I'm going to mark this is with the right angle symbol. And then my next one that says the measure of angle ABC, well, that's right here, so I'm just going to put that measurement inside the angle. And my last one, the measure of angle DBC, tells us what that's equal to. That's our other smaller angle inside the right angle, is x plus 1 over 2. Now I've taken everything that's in my given information, I've put it into my picture, and sometimes there's things that you're going to be able to notice from there that you could mark up. In this case, there's nothing else to mark, so I'm going to move on to step four. Step four was to state what you're trying to prove. And remember, if you have your if-then statement, this can be found in your conclusion. So I'm going to find what's in the conclusion. Well, my conclusion is x equals 27. So what I'm trying to actually prove in here is that x equals 27. Now when you look at this, I have the given information, I have what I'm trying to prove. If I slide back just one slide, notice we had the given information, we had what we're trying to prove. Now it's identical to what we had in the last one. So I can go through now, and being I've gone through step 1 through 4, this was step 4, remember, I can go on to step 5, which is write the proof. Now, please don't confuse that 1, 2, 3, 4, 5 steps I've just done with the different statements I'm going to write. Now I'm going to have multiple statements and multiple reasons. I'm going to number them 1 through whatever. But what I'm going to do now to start in statement 1 is I'm going to just start with all my given information. So statement 1, I'm going to take this first line, I'm going to clone it, make life easy, and then I don't have to write it again. So there's statement 1 for me. Well, my reason then is nothing more than given. The problem gave it to me. Step 2, I'm going to take my other piece of given information, this one, I'm going to clone this one, and I'm going to put this one right here. And again, my reason for this one, step 2, or statement 2 and reason 2 is going to be given. And I'm going to just use ditto marks to say that it's the same thing as above it. Step 3, well, I have another piece of given information, so I'm going to put this one in there. Clone that one, bring that one down. Again, this will be given. Now you will notice in some cases, Accelerated Math will do this, the book will do this, it will put all three of those statements together into one and call it statement 1, all that stuff, and then reason given. I don't like to do that because I like to break it into the pieces, because sometimes we may use this statement in one of our next lines, but we don't necessarily need this one. And this way we can keep them separate. So when you look at your reference numbers and it says use line 1 or statement 1, you'll know exactly which piece to use. Now from here, what I'm going to do in my statement 4 I'm going to do this. I'm going to take everything from here, and I'm going to put it right there. Because it's the measure of angle ABC. Well, it tells us the measure of angle ABC, so I'm going to put it there. And I'm also going to take all of this, the measure of angle DBC, and I'm going to put it right there. Because angle CBD or angle DBC, those are the same thing, so I can replace that. Now I'm going to take that line 1 and I'm going to rewrite it. But instead of putting the measure of angle ABC, I'm going to put what it's equal to. So from line 2, it tells me that that stuff is 3x minus 5. And then I have this plus sign. And then I have the measure of angle CBD, which I know is equal to x plus 1 over 2. And then that's going to equal 90 degrees. Now my reason, well, what I've done is I've replaced a number of different things with what those things were equal to. Remember, if you replace something with what it's equal to, you just used substitution. Substitution property. And when we look at this, I needed line 1, I needed line 2, and I needed line 3. I needed all of them. Now I just have to go through and solve my equation. I don't know if you guys are anything like me, but I really don't care for fractions if I don't have to use them. Sometimes they're great, and sometimes they're just kind of a pain. So right now I'm going to say I'm going to get rid of them. So I'm going to multiply the left side by 2, and I'm going to multiply the right side by 2. This will be 5. I'm going to call it I'm going to use the little time sign, multiplication property. In order for me to do that, I needed line 4 to kind of tell me that I was going to multiply. I'm going to move down here to statement and reason 6. So I have to remember, multiply everything on that left side by 2. So 3x times 2 put me at 6x. Negative 5 times 2 is going to put me at negative 10. And the 2 times the x plus 1 over 2, well, the 2's are going to divide out, and all I'm going to be left with is the x plus 1. And then 2 times 90 is 180. So my reason 5 is my substitution. I've replaced the stuff from line 4 and line 5 with what it's equal to. And you just heard me say I used line 4 and 5. Oops, this is reason 6. Alright, now on line 7, I'm going to put some things together. I'm going to put all my x's together and all my constants together. So 6x plus 7x, or 6x plus 1x is 7x. The negative 10 plus 1 is going to put me at negative 9. And then that's still going to equal 180 degrees. I did nothing more than substitution again. I replaced the 6x and x with 7x, the negative 10 and the 1 with negative 9. So substitution, using my ditto marks, and I need line 6. I'm going to add 9 to both sides. Let's work on solving my equation. So I use the addition property. And that would be from line, I needed line 7 to be able to do that. Line 9, that would be where I'd want to put my equal sign, and then I'm going to replace with things that are the 7x minus 9 plus 9 with 7x, and this with 189. So my reason 9, I'm using the substitution property again. And this would be from line 7 and line 8. Line 10, I'm going to divide both sides by 7. So my reason is going to be the division property. I needed to have line 9 to be able to do that. Now down here in line 11, I will be left with x equal to 27, using the substitution property again. So I used line 9 and line 10 to come up with that. Notice it says x equal to 27. What was I trying to prove at the very up here beginning? X equal to 27. So all of this, I have my statements, I have my reasons, I have my reference numbers, from where I started at the very beginning with the given information, all the way down here now to what I was trying to prove, that x equals 27. And that's going to conclude our lesson on, or our examples on how to write a two-column proof.